Tonight's regularly scheduled NOVA program will not be seen so that we can bring you this special NOVA presentation, Japan's Killer Quake.
It is one of the greatest tragedies of modern times. A quake so powerful, it knocks the Earth off its axis. A tsunami leaves tens of thousands feared dead. Parts of Japan shift 10 feet out to sea. Parts of the coast drop over 3 feet. What forces create this epic disaster? Now a team of scientists is looking for answers.
Never before have we had such a surplus of data. There are no mysteries in this earthquake. We know exactly what happened.
Japan's coast lies in ruins. Incredibly, it could have been worse. Scientists' understanding of earthquakes and tsunamis saved lives. But as this disaster shows, there is much more to learn. Japan's Killer Quake, right now on NOVA.
Major funding for NOVA is provided by the following: David H. Koch and
Discovering New Knowledge. HHMI.
and the Corporation for Public Broadcasting, and by PBS viewers like you. Thank you. Additional funding is provided by Millicent Bell through the Millicent and Eugene Bell Foundation.
It is 96 hours since Japan's largest earthquake in 1,000 years strikes. Professor Roger Billum from the University of Colorado is one of the first geologists to survey the aftermath.
So we're flying right over the coast right now, and much of the coast has sunk about a meter. The extent of the damage is truly amazing. The tsunami picked up everything in its path: cars, houses, warehouses, and just tumbled them relentlessly inland, on and on and on. One of the things I'd like to see is exactly how far it went, what kind of debris gets left behind on these gigantic tsunamis.
Every detail of the disaster is recorded by seismometers, strain gauges, and tidal gauges. Now Billum looks to piece it all together to find out exactly what happened and why so many lives have changed forever. How did this happen? March 11th, 2011, 2:46 p.m. Japanese time. 60 miles off the northeast coast, a massive earthquake. Seismic waves race towards shore. The fastest waves, called P waves, travel at 4 miles a second. 15 seconds later, they hit land. Japan's detection systems instantly pick them up. Within seconds, automatic warnings flash across the country. A computer-generated announcement interrupts a Japanese parliament broadcast. The coastal city of Sendai lies just 80 miles from the epicenter. There's almost no warning before slower, more destructive seismic waves called S waves hit the town. These slower S waves violently shake the ground from side to side. These are the waves that make earthquakes so damaging. Already, northeast Japan is descending into chaos. The seismic waves travel on. 93 miles southwest of the epicenter, they slam into Fukushima Daiichi, home to an aging nuclear power station housing 6 reactors. This video from a hospital near the reactor reveals the earthquake's power. Sensors at the plant automatically shut down the reactor cores. The reactors are in lockdown when the S waves hit. But the intense heat generated from the nuclear reaction process does not simply dissipate.
When you think shutdown, you think, the danger's gone because it's shut down. But the reactor core was still extremely hot. You know, if you have a pan in the oven and you shut the oven off, that oven continues to heat inside even after you've turned it off.
With the reactors stopped, there's no power to drive the cooling pumps. The reactor cores heat up. Emergency diesel generators take over, pumping coolant through the reactor. The Fukushima plant survives the earthquake intact. Scientists 3,800 miles away at the Pacific Tsunami Warning Center in Hawaii receive emergency alerts. Researchers around the world see the event unfold.
Japan has lots of seismometers, so there was a lot of information fast. So the earthquake was still going on when we got our page.
First indications, a magnitude of around 7. But as data floods in, the numbers start to climb. 7.5, 7.7, up into the 8s.
The immediate reaction of everybody was, that's not right. Because in the history of Japan, there has never been an earthquake larger than 8.4.
Really heightened the intensity of what we were doing, because we knew we were dealing with something very big and something that could affect the whole Pacific Basin.
We realized, oh, this is it. And then immediately you realize, this is horrible for Japan.
The source of this disaster lies 62 miles off Japan's coast. 4 miles below the surface, the Earth is distorting, caught in a vast slow-motion collision. The Earth's crust is made up of several continent-sized slabs of rock, tectonic plates. Japan lies at the point where the Pacific Plate rams into the Eurasian Plate at 3 inches a year, about the same speed your fingernails grow. Japan is on the Eurasian Plate. It compresses and buckles as the Pacific Plate drives underneath it, snagging and catching as it goes. Over centuries, immense stress builds up until suddenly the plates snap, causing an earthquake.
The energy that drove this earthquake had been building up for a couple of 100 years. It's caused by the movement of the Pacific Plate towards the Eurasian Plate. Think of it as a giant elastic band that's being wound up for 200 years.
100 seconds since the fault line slipped, the destructive S waves reached Tokyo.
Tokyo 渋谷のスタジオが非常に大きく揺れています。東京の渋谷のスタジオが大きく揺れています。
The city has 60 seconds warning. The quake lasts an unprecedented 5 minutes. An American geologist is in Tokyo.
We expected it to end after 10, 15, 20 seconds, something like that, maybe a minute at the most. About minute 3 or 4, we were just all kind of astonished that it just kept going and going and going. We're just looking at each other going, is this over yet? And no, it's not, it's still going.
What is different about a big earthquake is that it begins, but it doesn't stop.
It was kind of a growing realization that it was just getting bigger and bigger and bigger, and it had to be fairly close.
An American tourist captures the ground opening up at his feet. The footage reveals a frequent characteristic of earthquakes: liquefaction.
Okay, we have earthquake right now, and this is actually moving. Can you see the cracks moving? That crack was not there. That crack is getting bigger and smaller, going back and forth. And there is water coming up all over in the park right now.
Loosely packed and waterlogged ground near the surface starts to behave like a liquid. As the ground compresses, liquefied dirt pumps to the surface. Most buildings still stand. Japan's earthquake warning systems work. Scientists upgrade this quake to a magnitude 9, 1,000 times more powerful than the devastating 2010 Haiti earthquake. But everyone in Japan knows this is far from over. The earthquake's explosive energy is about to unleash another destructive force. For centuries, the Eurasian plate is dragged downward by the Pacific plate grinding under it.
The whole upper plate behaves just basically like a rubber block. It just compresses, and like a spring like this. And when the earthquake happens, it springs back.
The upward motion thrusts a 4-mile deep mass of water upwards.